let's start our lesson for the day. You know, I was joking with my wife last night. I was like, we'll go into like these random things. And we'll be like, okay, now. So here we go. Another instance. Isosceles and equilateral triangles. The reason why this lesson is so short is because you all already know about isosceles and equilateral triangles. In fact, this is really just a review of some of the stuff you learned in geometry. So, equilateral. Clearly means equal. Lateral, we learned. What does lateral mean? Lateral. If I throw a lateral pass in football, I go to the side. Remember, quadrilateral, 4 sides. So, equilateral means equal sides. So, an equilateral triangle, what do we know about all the sides of an equilateral triangle? They're equal or congruent. Exactly. The measures are equal. Good. So, the measures of all the sides of an equilateral triangle are equal. All the sides are congruent. What do I know about the angles? The angles of an equilateral triangle. They're all congruent. Now, what do the angles of a triangle add up to? 180. So, if all the angles are equal, what are the angle measures of an equilateral triangle? 45. Think. 60. 180. 3 angles. 180 divided by 3 is 60. So, all the measures of an equilateral triangle are always 60 degrees, no matter what. Is that pretty clear? So, equilateral, congruent sides, equal angles. What would be a word that I could use to say equal angles? Equiangular. Equiangular. So every equilateral triangle is also equiangular. Every equiangular triangle is also equilateral. Does that make sense? Okay. Next is isosceles triangles. An isosceles triangle has what? What's the property of an isosceles triangle? Yeah.
2 equal sides.
2 congruent sides, good. And 2 congruent angles. 2 congruent sides, 2 congruent angles. The congruent sides of an isosceles triangle, if you took a look right there, they're called the what? Legs. Good. And the 2 congruent angles are called the base angles. And the angle that's not the same as the others is called the vertex angle. And the way to kind of think about it, and this isn't always the case, but like if this was like a pyramid, that would be the base of the pyramid, that would be like the vertex of the pyramid. But if you rotate it, obviously, it would be like different. So the point is the base angles are the ones that are congruent. The vertex angle is the one that is not. And the legs are the 2 sides that are congruent. With that said, actually, I don't know if I have enough code right here. I'm going to see if I can get you guys doing another cool project. Maybe later. So with that said, let's go ahead and do an example. So everybody turn to page 743. So here we've got a word problem. Katie is stitching the center inlay into a banner that she created to represent her new tutorial service. Okay. All of that is useless to me. It is an equilateral triangle. That's useful. With following dimensions in centimeters. What is the length of each side of the triangle? Okay, so it's an equilateral triangle, so what do I know about these 2 sides? They're congruent, right? The measures are equal, all right? So if I want to figure out the length, what would I need to solve for? What variable? X. Okay, so how could I solve for x?
6x minus 5 equals 4x.
Yeah, good. I know that these two sides are equal, so I set them equal to each other. Guys, let me kind of demystify this for a second. If I need to solve for a variable, what do I always have to create? An equation. If I want to solve for a variable, I have to create an equation. So the question is not what do I do as much as what equation can I create? And so the equation that I can create is 6x minus 5 equals 4x plus 7. I set the sides equal to each other because it's an equilateral triangle. And then from there, I just solve. Subtract 4x from both sides. I get 2x minus 5 equals 7. Add 5 to both sides. 2x equals 12. Divide both sides by 2. X equals 6. Am I done? Or do I have to do another step? What do I do? Plug it in. Very good. So I plug it in. Doesn't matter which side I plug it into. It shouldn't, because they're equilateral. So 6 times 6 minus 5. 6 times 6 is 36 minus 5 is 31. 4 times 6 plus 7. 4 times 6 is 24 plus 7 is 31. It's equilateral, so if I've done it correctly, they should both be the same. That's also a way that you can check your work. If you solve for x and you get some weird answer, and you plug it back into the side lengths, they should be equal no matter what you get. Yes, ma'am.
So that side is also 31.
Yes.
On the left, so on there.
Yep.
So why didn't they leave the angle like congruent for all three?
You know what? That's a very good question. I don't really know the answer to that. I think that was just a misprint. They should have shown that that was, because it's an equilateral triangle, so
Right, yeah.
they should. Good job. Very good. Good observation. Any questions about this? Okay. So I'd like you guys to go ahead and do this one. So page 744, you're going to have to get familiar with angles because there's lots of them in this one. I'm sorry, fractions rather. There's lots of fractions in this homework assignment. And also there are lots of questions that end up with fractions as answers. So don't be afraid of that. So go ahead and solve for the sides of this triangle. Solve for y first, then solve for the sides. All right, let's take a look. So the sides are congruent. That means their measures are equal. So to solve, I just set them equal to each other. Now, I could work with this thing in fractions, but I'd rather not. How do I get rid of those fractions? What can I do to both sides to get rid of those fractions? Multiply by. If I multiply by 5, I'll get rid of this fraction, but I won't get rid of this one. So I've got two denominators, 5 and 10. So I have to multiply by the least common multiple. Least common multiple. What's the least common multiple of 5 and 10? 10. If I multiply by the least common multiple, then I will always cancel out the denominators. So let's take a look. 10 times 3 is 30 over 10 y plus 10 times 9 is 90 equals 4 times 10 is 40 over 5 y minus 1 times 10 is 10. I simplify. 30 divided by 10 is what, class? 3. 3y plus 90 equals 40 divided by 5 is 8y minus 10. Good. So you see, by multiplying by the least common multiple of the denominator, I always end up with canceling out the denominators. Then I just solve as usual. Subtract 3y from both sides. 90 equals 5y minus 10. Add 10 to both sides. I get 5y equals 100. Divide both sides by 5. Y equals 20. Okay. Any questions about that? Yes,
Do you want to see the step where you get rid of the denominator, or is it okay if we keep the fractions?
you mean this step?
Yeah, well, like, for example, I just made both of the denominators 10 and like worked it out that way.
Oh.
And like got the same answer.
Yeah, sure.
Okay, so you don't like.
No, that's totally cool. What Jenny was just describing is changing 4 over 5 to have a common denominator with 3/10, and then you can work with the fractions. So you can work with the fractions or you can get rid of the fractions. Those are always the options. So y equals 20, that's good, but I'm not quite done. I have to plug it in. So I'll plug it in here. 4 over 5y, so y is 20, so 4 over 5 times 20 minus 1. Well, some of you guys might get confused here. Do I multiply the top or the bottom? Well, 4 over 5 times 20 is the same thing as 4 over 5 times 20 over 1. So I only multiply the top. I get 80 over 5 minus 1. 80 divided by 5. If I have to, I can do my long division. 5 goes into 8 one time, minus 5 is 3. Bring down to 0. 5 goes into 36 times. 16 minus 1 is 15. So my side lengths are 15. And if I were to plug it into here, I should get the same thing.
Can you just cross multiply? Like cancel out the 5 and the 20 and then.
Turn it into a 4?
Yeah.
Yep.
Okay.
Yeah, there's lots of things that I'm not showing you guys. Like, for instance, right here, I could have just crossed out that 10 immediately. Right? I didn't have to turn this into 10 times 3 over 10. I just see, oh, it's 10 over 10. Those cross out. And here, I could have crossed out the 10, crossed out the 5, and then multiplied by 2, because 10 divided by 5 is 2. Does that make sense? There's a lot of shortcuts that I'm not doing, because if you know those shortcuts, then you'll do them anyway. But if you don't know those shortcuts, they would be confusing. Does that make sense? But there's lots and lots of shortcuts that you can always do when working with fractions. It's just about getting the hang of them and getting to know them. And what Jenna was just saying is 20 divided by 5 is 4, so I can cancel them both out and just turn that into 4. And then 4 times 4 is 16. Does that make sense to you guys? Okay. So the way I will generally default to is like the longest, most rigorous way of doing the problem, because it's also the most clear, but there are always shortcuts to do. All right, so the answer to that was y is equal to 15. Now I'd like to bring up the next type of problem, and this is the second type of problem that you're really going to see in this homework, and it's also a little bit more challenging to understand, so it's important that you do pay attention. So this is the type of problem that you're going to see where you have an isosceles triangle rather than an equilateral triangle, and this is page 743 in the middle right there. So in this case, you're asked to solve for angles, okay? You're asked to solve for angle T, which is this angle right here. Okay, now the only thing that I know by default about every triangle is what? The angles of every triangle, what? Add up to 180. No matter what the triangle is, I know the angles all add up to 180. And so that's kind of one thing. Okay, I know the interior, some of the interior angle measures is 180. But this is a special triangle. It's an isosceles triangle. So I know something else about its angles, right? What do I know about the base angles? They are the same. They're congruent, right? So if this angle is x, angle R is x, then what is angle S? X. So that's what I know. So I know that these two angles are congruent, so those are both x degrees. So now, what should I do? If I want to solve for measure of angle t, I have to solve for x first. The question is always, what equation do I create? Well, what's the only possible equation that I can create? What did I say? That one piece of information we know about all triangles. Their angles all add up to 180, right? So, yeah, add them all up, set them equal to 180. That's an equation you can always use. X degrees plus 3x degrees equals 180. And if this is confusing, you can kind of put like a 1 in front of both of these. 1 plus 1 is 2, plus 3 is 5. So that becomes 5x degrees equals 180. Divide by 5. And we get x degrees equals 180 degrees. So x is just equal to 180 divided by 5. Guys, don't be afraid of scratching out the long division real quick. I've seen over and over people just trying to think of it in their head, and it takes 30 seconds when if you just do the long division real quick, you're just done. 5 goes into 1, no. 5 goes into 18 3 times. 5 times 3 is 15. Minus 15 is 3. Bring down the 0. 5 goes into 36 times. So x equals 36. Good. Am I done? No. I have to plug it back in here. 3 times 36 is 108. So the measure of angle t is 108 degrees. So what were the steps there? Recognize the base angles are congruent, add them up, set them equal to 180, and solve. Any questions about that one? Okay. That's basically it. But let's go ahead and do this example on your own. Page 744, on the top of page 744, number 5. It says your turn. Okay. Let's give it a shot. So I see these two sides are congruent. Therefore, I know these two angles are congruent. So this is also 3x plus 3 degrees. Add them all up. I get 3x plus 3 plus 3x plus 3 plus 5x minus 2 equals 180. 3x plus 3x is 6x plus 5x is 11x. 3 plus 3 is 6 minus 2 is 4 equals 180. Subtract 4 from both sides. I get 11x equals 176. Divide both sides by 11. And I get x equals 16. X equals 16. It says find the measure of angle P. That's that one. So I do 3 times 16 plus 3. 3 times 16 is 48, plus 3 is 51. So the measure of angle P is 51 degrees. Any questions? Yes, ma'am.
How do you know when to set if the equations to 180 and when to set them to each other?
Very good question. When they're angles in an isosceles triangle, then you have to do it this way. Because you're solving for the angles, so you know they add up to 180. But the sides of an equilateral triangle, the sides would never, when you're doing sides, they would never add up to 180 because it's only angles, right? So the sides of an equilateral triangle are congruent. That's when you set them equal to each other. Does that make sense?
Yes.
Okay. All right. Any other questions? All right. So that's basically the lesson for the day. So what is your homework? Your homework is page 746, numbers 3 through 3 through 18. I'm sorry, number 4 through 18. 4 through 18. And then number 21 is extra credit. So numbers 4 through 18 and 21 is extra credit. So you've got about 10 minutes, almost exactly. Page 746. Go ahead and get started.